Aloha! Welcome to my channel, The Curvature Amateur. Just to warn you, this video is probably the shortest distance of observation I have throughout all my videos. So don't be too disappointed at the end to see the end result. But please stay tuned because it's good to add into your little pocket book of knowledge. So today we're going to be observing two things. We're going to be observing fairies going down under. And we're also going to be looking at a power station across the Long Island Sound. And where I was in Bridgeport, Connecticut. Let's take a closer look at it. A little peninsula called Lordship. And that's where I was, right by the beach. Beach is very flat here. If you walk out, you can't really get tired over that. You see a couple of people standing, and that's where I was, standing with my tripod and my Nikon P900. My camera lens was about 10 feet over the water level. Okay. And I was observing straight across the Long Island Sound, which is about 10 miles wide, where I was looking. And from Bridgeport here is where the ferry leaves the port to cross over to Port Jefferson across here. So let's go take a little look across the water, what they got on the other side. Oops. So we see the ferry in action going in and out of Port Jefferson towards Bridgeport across. But we're also going to be looking at Polkwat, this little power station here. I want you to be remembering a couple of details. First are the tall chimneys, obvious tall chimneys, and then there's another chimney or silo. There's another silo here. And if you look down here, painted on that wall is an American flag. It's kind of backwards, but it's still an American flag. It seems to go all the way down to the ground level, and you can see some cars parked there at the ground level. And on the top of that building, it's kind of shaped with two squares on the very top of the building. And we can count how many stories there is that building made out of. 1 story, 2 story, maybe 3, 4, 5 story. I'm not sure. Hard to say from this angle. Maybe in 3D we'd get a... That was 3D. Maybe by leaning over we can see something. Not so much. Okay. So another thing to observe is on that ground level here is a little bridge leading to this dock. So the dock here cannot be very high up. We'll even go and check out the elevation there. Okay, in Polkwat, zoom in a little bit closer. You can see pretty much the same picture. So let's take some samples of elevation of the ground there. And we got 10 feet, that makes sense. How about on the dock here? 10 feet, same thing. It doesn't slope much. 7 feet over here. 7 feet over there. So we're very low. I'm about the same height on the other side of the Long Island Sound, 10 feet. Okay, so you can see here, it looks like the American flag goes all the way down to the ground with this picture. All right, just bear that in mind. Let's get out of here. Okay, so what we're doing here on my curvature amateur videos is we're observing the curvature of the Earth. But the curvature of the Earth, of course, doesn't leave our Earth so flat. Doesn't make our Earth flat at all to have curvature. But does it put us on a globe? Let's see. Earth calculator. There are several websites how to calculate the Earth the Earth curvature, and they pretty much wind up all the same results. Okay, and the formula is basically squaring the miles of observation times 8 inches per foot, which is 2/3. Okay, let's take a closer look at that. My favorite website to explain is this one, Curvature of the Earth on Math Central, because they have a little drawing. A little drawing like that help us to understand the simplest things. So this little circle they have here represents the ball Earth. Okay, the globe that we're supposed to be standing on. So Robert here, the expert, who was asked by other people at all level, okay, so what would be in 1 mile, what would be the distance we wouldn't be able to see anything below that height in 1 mile. Okay, remember we got to square that distance of observation. 1 mile, 1 square is 1. They use a Pythagoras triangle to figure out that formula, a square plus b square equals c square. Okay, very simply. And they use this number here, which they think they know that the radius of the Earth sphere is 3,963 miles. Okay, it looks like a precise number to me. It's a whole number, yeah, there is no decimals. It's not 3,900 miles, it's not 4,000 miles, it's not even 3,960 miles. They added a little 3 miles in there to add some precision. And just to remind you, in math, it's kind of good to have precision. Okay? So with 1 mile, they figure out that we lose 7.98 inches of the ground surface we're not be able to see, which is approximately 8 inches in 1 mile. Okay, let's pull out our calculator. All right, just to show you the value of 2/3, if you don't know that, is 0.6 periodical. Okay, 8 inches out of a foot is the same value, 2/3, 0.6 periodical. And now we want to know how many, what's the proportion of this here? 7.98 inches into a foot, 12 inches. So we get 0.665. It's just a tiny bit less than the value of 2/3. All right? So let's go back to our map here. We're going to be zooming out. And we're going to be taking a measurement. Let's turn it around to fit a little bit more in the screen. Okay, so I want to measure to Port Jefferson here. Measure distance to Stratford Seawall in Lordship, Connecticut. So what we got is 13.94 miles, okay, which is about 14 miles, give or take. All right, let's pull out our calculator here. Let's just do it again. Let's measure it once more. Right here on the edge of the water. See, just under 14 miles. We can be precise and put that exact number here. Whoa, not what I want to do. Here, okay. So 13.87 miles. Okay, times itself, we're squaring that number of distance. So we get 192. We multiply that by 0.665, which is just a bit less than the value of 2/3. So therefore, according to this here, according to this website and all the other websites that talk about curvature of the Earth, they calculate it for you. You're going to wind up pretty much with the same value here. Okay, do your math all you want. So I shouldn't be able to see anything below 127 feet. Okay, at 13.87 miles. Bear that in mind. Okay, to 127 feet. Okay, so first let's take a look at some fairies. See some fairies in action. Not those little bugs that look like humans, but the boats that carry cars and people over water. Alright, so I'm standing there, very windy. Okay, I'm not by the Stratford seawall, I'm just a little further on the coast. But what I want to show you here is a ferry in action, just coming out of the Bridgeport. See, that's our power station across here we're going to be observing. That's not what I want to show you right now. I want to show you a little bit further. Here we go. Here's a ferry. So looking at this ferry, okay, it doesn't have any cars for now. Let's just back it up a tiny bit. Okay, if we notice the ferries, the bottom of the ferry is black. You see, the bottom strip is painted black. Nice contrast to the white. So let's look at our ferry here. No cars right now. Okay, how tall can this be here? Looks about half the height of the whole ferry is this floor here. So this floor we can fit tall trucks in there. And it's like a 2-story, maybe 3-story building, this thing. So would you say like 12, 24, 36 feet tall? Okay. You see the ferry. Alright, so let's take another look at that, at a ferry from a different point of view. This video. Now I'm on the Stratford seawall in Lordship. And we can see some big boats out there, and I want to take you further down my video. A little bit more. Okay, here we go. All right, so we see on the ferry it has some vehicles now. And you can see a car. Shorter than me, I'm 5'8". A van here is taller than me, and it looks like a UPS van up here, which measures about 10 feet high, if not more. So if this is 10 feet high, its floor is around where the black line is. 10 feet, another 10 feet, maybe another 10 feet, so 30. Yeah, we're about 40 feet. Maybe at the top of this ferry wall. And it looks like a standing person here, which measures probably under 6 feet. can probably say 1 person, 2 person, 3 person, 4 person, 5 person, 6 person. Yeah, you can say about 40 feet high. Okay. Now let's look at. I got a little video here. Again, by the Stratford seawall. Okay, and I'm going to skip ahead. Nice lighthouse of the old world across. Just want to show you. Skip it, pass it. So that's looking straight across the Long Island Sound from Lordship. And remember, my camera eye is about 10 feet over the water level. And we should be seeing, if you're patient enough, a few features that is going to clarify the shape of our Earth. So here we got the Poquat power station across. Remember, we're 13, almost 14 miles across the Long Island Sound, and my camera eye is at 10 feet over the water level. And if you notice here, there's the American flag. It's painted backwards on that wall. If it has any symbolism to be painted backwards. So remember the tall chimneys here, that other chimney, it looks a bit like a silo or whatsoever. I don't see that other little silo in the front, but it doesn't matter. Main thing is we recognize that flag here, and we also recognize the 2 square parts on the top of that building, okay, which is what, maybe 12 feet tall in an industrial building like that, to have one level, 24, 36 feet. And if we look at the proportion of a flag, the flag should be just down to the ground, a bit lower than the water level here. If we could fit a well-proportioned flag in this image. So we're not missing much of the ground level. We can even see the first floor. It seems like the first floor of that building here. Remember, 1, 2, 3 level, 4 level floor. We can go back to our map here just to compare. Even this one here was showing us some details. So look, we got 1 floor. It looks like it might be a little bit more than 1 floor here. Another floor, another floor, another floor. 1, 2, 3, 4, 5 levels. And what do we see on my video? 1, 2, 3, 4. Maybe there's one missing. Okay. So how much feet do you think this justifies here? 20 feet, 30 feet, 40 feet? Okay. And remember our map. Our calculator here, we shouldn't be able to see anything below 127 feet at almost 14 miles across here. And remember, the ground level there is 10 feet, and I'm at 10 feet. So you can maybe subtract 20 feet from the equation, okay? And maybe add maybe 20, 30, 40 feet if you want. You know, that we would be missing from that ground level. We're still pretty far away from reaching that 127 feet that would be missing. I mean, that we shouldn't be able to see anything below that, according to Robert, the expert, and everybody else that put out a website claiming that they know how to calculate the Earth curvature. So therefore, according to these math, we're far from being on a globe Earth, from being on a ball Earth. Okay? If I see curvature on my knee, does it mean my knee is round? Most people's heads look kind of round, but does it mean that they're a ball? No. Even if the sun and the moon we see up there look like balls, doesn't mean that the Earth we're standing on is one too. Doesn't mean that if NASA is showing you that we're going in space, that we really are going in space. Because remember, it's all in the camera's trick. And I have no tricks in my camera. I'm not that talented. All I have is a Nikon P900. I zoom in, zoom out. I can change the type of exposition on my lens, but no, sorry, I'm not talented enough to trick videos. And if this look trick to you, if you want to see the tricks, you can look and look if you want. Waste your time. All right, so let's just keep on looking across the Long Island Sound here. Remember, that's the bay that those ferries go in and out of. But I can't even see the shoreline between. Just remind you. No. Just to remind you. See, we can't even see that part of the land here. We just see over it, thanks to the curvature of the Earth. We see straight towards that station as if this part of island or peninsula wasn't there at all. All right, let's keep on watching my footage. Nice boats. So if you notice the houses across, it seems like their basement are dipping in water. Is the Earth really flat? Here's our ferry. We definitely do not see the black line over the water level. We do not see where the cars are parked, so we're missing a whole bottom level of the ferry. Remember that UPS van, 10 feet tall? So we're about seeing a half the height of the ferry. But we cannot tell how far away that ferry is. But you can see that it's gone beyond the curvature. Yeah, ferries wear boots and you gotta believe me. Yeah, I saw him, I tell you no lies. Yeah, ferries wear boots and you gotta believe me. I saw it, I tell you no lies. Oh, right now. So I went to the doctor, so what he could give me. He said, son, you've gone too far. 'Cause smoking and tripping is all that you do. Yeah. Again, we have a ferry going under. You see, we don't see the bottom floor. You don't see the cars. So it's gone beyond the curvature. It went up and down on the other side. Does the water really curve? People say, no, water always finds its flatness. Well, take up a cup of water in your hand, or take up a glass of water, or an empty cup of glass. Okay? Fill it slowly. Fill up your cup slowly with water, and look at the edge of the water touching the glass. It either curves downwards or upwards. It does curve. All right, here, what we got, we're going to be looking at that with the map in a second. You can see the you can see this building. Recognize the shape: squares, squares, squares. Okay, obviously, it's very specific shape, this building. You can see here the houses. They look like their basement are in water, and it doesn't look like much distance between these houses and those things here. Back to my map. So I put it away too early. Just want to show you some features real quick. Jefferson. Spin that around because we're looking from the other side. Then 3D. Stony Brook. What is there in Stony Brook to be seen? What do we got here? Recognize this? The Children's Hospital, or what is it? University School of Medicine. Should we trust these guys? See, recognize that building? That's what we can see from Lordship. Okay. See where it is, how far it is from the coastline. Okay, let's take a measurement from the coastline. See, it's over 4 miles away, 4.5 miles away, and it looks like it's very close, isn't it? Isn't that amazing? Anyway, like I said in the beginning of my video, this is the shortest distance of observation I have throughout all my videos. So please watch more of my curvature amateur videos. If you want to know what kind of earth we live on, if you want to have a good idea. Also have my videos on BitChute. So see you next time. Aloha.